Welcome everyone to the online open day for the Master of Materials Engineering at K11. As you may know, materials are at the heart of our quality of life and economic welfare. And this master aims at educating you so that you will be able to design new materials in the future and make sustainable choices, both at an industrial and at an academic environment. How will you do that? These capabilities will be based on a thorough understanding and use of the relationship between one, the internal structure of materials. That means crystal structure, microstructure, and morphology at the nanoscale. Two, the properties of the material, either mechanical, electrical, or chemical. And three, the processing of this material. So this relationship between structure, properties, and processing of materials is what we call the materials triangle, and you will learn about that in our master. Materials are everywhere, right? You can find them in construction, in vehicles that aim at lightweight and stronger materials. You will find them in electronics that they are continuously looking for new and more performing materials to improve our electronic devices, and these days even more and more in biomedical applications. This prevalence of materials will continue to be there also in the future, especially considering the current need that we have to build a sustainable world and to use our resources very intelligently. This is actually especially critical in Europe because we are very limited in the availability of materials, and it is important for us to use them smartly. Indeed, we are at the forefront of recycling in Europe, and this will be also reflected in our master. Materials engineers invent, design, make, and use materials for products, processes, and services. In this master, you will be educated for leadership in sectors where materials play a decisive role, and you will gain the necessary skill set to jump into a competitive job market. Where can our master students expect to work? Materials engineers are prepared to work as process engineers, materials or product developers, design specialists, quality control engineers, and more general jobs such as consultants. Of course, graduates with an interest in research can continue their career through a PhD, and some of alumni has even started their own companies. So, let me introduce you to some cases of success coming from our department. For example, Jeroen Hullens completed his PhD with us in the Department of Materials Engineering, and he is now working at Umicore as the Director of Pyrometallurgy. Umicore is a big Belgian multinational company with a strong emphasis also in R&D, and one of his main core business is to recycling materials, with special emphasis in recovering critical metals. And the way they are doing is that they are also getting involved in product design where these materials are used. So they get their hands in the whole process, from the design of the product to the recovery of the metals. Those are some of the examples of these critical metals that are very important to be recycled, especially in Europe because we don't produce them. And some examples of applications are, for example, in catalysis, in exhaust pipe of any car. You need metals such as platinum or palladium. In any battery, in your portable device, in your cell phone or in your laptop, most likely you will find also a lot of lithium and cobalt in the electrodes of the metal. On the electrode of the battery, sorry. And For example, in thin film photovoltaics, we can find other metals such as copper, indium, selenium, and germanium, which are considered scarce or rare. And it is very important that we can recover them after use. The production of these metals, as you may know, is actually not very uniform in the world. So, for example, most cobalt is produced in Congo, or lithium is mostly produced in South Africa, and rare earth or other metals such as bismuth or indium or other materials such as germanium are produced in China. So this non-uniform production creates some tensions, and it makes it very, very important for Europe to be able to at least hold into the materials that we already have through recycling. Two other cases of success coming from our department are those from Michael Callens and Niels de Greve, who completed their PhD and master respectively with us. After that, these two gentlemen started up their own company, which key technology was to develop a composite material made of carbon and steel fiber reinforced polymers. And they apply such material that you can see here on the right hand side is woven fibers of carbon and steel. They applied to bike frames. And they show that their material has an advantage over traditional carbon reinforced polymer bike frames because it significantly improved the impact resistance. As you can see here on the left hand side, their material versus traditional carbon reinforced bikes. So that means that upon an impact where a normal bike frame would have suffered a sudden fracture, the material developed by Michael and Niels could actually survive. Yet another case of success is the one of Thomas Lapo, Lucas Arnaud, and Walter Crane, who did their PhD and master also in our department. And after that, they created their company Resourceful. Resourceful is developing cement and concrete made from metallurgical slag. So metallurgical slag is a byproduct considered as waste in the metal industry. So usually this slag goes to the landfill. Instead, what Resourceful is doing is reusing it to create decoration bricks that can have different color depending on the slag that you use, as you can see in the picture. And on top of that, they are developing a cement which is much greener than the traditional Portland cement. Why? Not only because they are already using waste material to produce it, but also because they can skip this carbonation step chemical reaction that produces CO2. As you can see on the right hand side figure, CO2 is responsible, cement is responsible for 8% of the CO2 emissions worldwide, which is much more than aviation, much more than transport, and almost as much as residential heat and electricity. So you can see the importance of this kind of technologies. So let's take a look at our English Master in Materials Engineering. It has a total of 120 ECTLs, from which 60 credits correspond to the core courses in Material Science and Engineering. On top of that, there are 12 credits in optional subjects that cover the main material families, such as metals and ceramics, polymers and composites, nanomaterials and electronic materials, and also biomaterials. On top of that, you can select elective packages, which are supposed to help you orienting your future professional career towards either research or more industrial jobs related to management and production. To complement your core courses, you can also choose 6 credits related to engineering, other kind of engineering, not only material science and engineering. And finally, to satisfy your personal general curiosity and broaden more your intellectual horizons, you can choose 6 credits of general interest courses that include languages, economy, and more humanities-related subjects. And last but not least, very important, 24 credits of a hands-on master thesis. Going more into detail in the 4 options that you can find in our master to focus, you can choose to study the latest development in metals and ceramics. For example, those aspects related to recycling, additive manufacturing, studying and testing plastic deformation, latest alloys, functional ceramics, etc. You can also go in detail into polymers and composites, which goal is to create materials that are lighter and stronger by mixing 2 phases, where one of them is a polymer and the other is a filler, and you put them together, you can create more than each single phase individually. We will also offer insight into materials for nanotechnology and nanoelectronics, and those are the materials that you will find inside all your electronic gadgets, but not only that, also also materials for energy, such as those used for solar cells or for energy storage in batteries, etc. And finally, the 4th option are materials for biomedical applications. Those are materials that need to be compatible with biological system, either to be implanted into the human body or that are used to create prosthetics, etc. In addition, with our standard master, we also offer a master program in sustainable materials called the SUMA program. This is an European program also consisting of 120 credits, where the core courses and the master thesis are identical to our normal standard program, but this program has a stronger industrial aspect because it includes industrial partners that help linking to the job market. And this is why this program also includes an internship of 6 credits, and if you are interested, here is the link for you to explore further. The SUMA program, which is based on sustainable raw material and include recycling and circular eco-design and life cycle engineering, as I said before, it's an European program, which means that you can do each year of the master in a different countries. For the first year, there are 4 different tracks. K11 is the track number 1 in sustainable materials. There's a similar track also in University of Trento. Track 3 is about materials development and in University of Milano Bicocca, and the track 4 is on sustainable metallurgy, and it takes place in the University of Leoben in Austria. Then after a summer school, for the second year, you can go to a different institution. So basically K11 welcomes students from tracks 2, 3 and 4. To know more about our admission requirements, you can visit our website for academic requirements, and it's also very important to highlight that this is an English master. So we require proficiency in English, certified by one of the standard tests, a minimum of 7 in the IELTS or of 94 in the TOEFL, also with requirements for the minimum sub-score as it's detailed in this slide. Finally, regarding K11, I would like to remind you that K11 has been nominated for 4 years in a row as the European most innovative university, and this is related to patents production, technology transfer and startup. And our program in materials engineering has been also ranking top 100 in most of the ranking, and some of them even top 50, like the top university ranking, and we hope that this progression will continue going up thanks to you in the future. Thank you very much for your attention, and please feel free to visit our website if you need more information.